continue our lesson on solving absolute value inequalities. So yesterday we talked about the basics of solving absolute value inequalities, how we need to determine whether we have an and statement or an or statement. And sometimes we won't know whether we have an and or statement until after we finish simplifying a little bit, because your inequality symbol might flip. In a regular inequality symbol, if you divide by a negative number, so here's a little example, negative 5x is greater than 25. I divide by negative 5 on both sides. When I divide by a negative in an inequality, it flips the inequality symbol. So it flipped from greater than to less than. So I end up with x is less than negative 5. So the same thing happens in an absolute value inequality. So here I have a little example. Negative 3 times the absolute value of x minus 2 is less than or equal to negative 9. So the way it is right now with less than or equal to, it looks like an and statement. However, when we divide by the negative 3 on both sides, that eliminates the negative 3, so we're left with absolute value of x minus 2, but when we divided by that negative 3, the less than or equal to symbol flipped to a greater than or equal to symbol, so we get the absolute value of x minus 2 is greater than 3. So it's really an or statement. So you have to be careful. Do you have an and statement or do you have an or statement? If you don't have a negative being multiplied, you don't have to flip your inequality. But if you do have a negative, then you need to make sure you flip your inequality. Be very careful with that. So let's move on to our examples. So here we have our first example. We have negative 4 times the absolute value of 3x minus 7 plus 16 is greater than or equal to 0. So my absolute value is not isolated, so I need to isolate it. So we're going to subtract 16 from both sides, eliminating the 16. We get negative 4 times the absolute value of 3x minus 7 is greater than or equal to 0 minus 16 is negative 16. And now we're going to divide by a negative 4. Reducing the negative 4, we get the absolute value of 3x minus 7. We divided by a negative, so this greater than or equal to symbol flips to a less than or equal to symbol. Negative 16 divided by negative 4 is positive 4. And now we have an and statement. So we're going to say 3x minus 7 is less than or equal to 4, and 3x minus 7 is greater than or equal to negative 4. And then we solve. So we're going to add 7 to both sides here. And we get 3x is less than or equal to 11. Divide by 3 on both sides. And we get x equals the fraction 11 over 3. On the other side, we're going to add 7 to both sides. And we get 3x is greater than or equal to positive 3. Dividing by 3 on both sides, this reduces, and we get x is greater than or equal to 1. And this is an and statement. So now we can mark this on our number line. On one side of the number line, we have negative infinity. On the other side, we have infinity, and 0 is somewhere in the middle. Now, we need to figure out which one's the smaller number. 11 over 3 is approximately equal to about 3.6. Okay, this is approximately equal to 3.6. So this is bigger than 1. So we're going to mark 1 on the number line right here, and we're going to mark 11 over 3 a little bit further down. Okay, and this should be less than or equal to. I apologize for that. I accidentally put equal, so it's less than or equal to, and that is greater than or equal to. Okay, so now this is x is less than or equal to 11 over 3. The or equal to part, the little line underneath, means that 11 over 3 is closed. So at 11 over 3, we're going to put a closed bubble. The same thing happens at x is greater than or equal to 1. I have greater than or equal to. Since it's also or equal to, at 1, we have a closed number. So we're going to bubble it in. Now this is an and statement. So since it's an and statement, we shade in between. So now for interval notation, we're starting at 1. 1 is closed, so since it's closed, we use a bracket, and we're starting at 1, comma, and we shade until we get to 11 over 3. 11 over 3 is closed, so we're going to close it with a bracket. And this is our solution for example 1. Okay, so example 2 is negative 6 times the absolute value of 5x plus 15 plus 60 is less than 30. Our absolute value is not isolated, so we need to isolate it by using reverse order of operations. In order to do that, I need to subtract 60 first from both sides. So that's going to eliminate the 60, and we get negative 6 times the absolute value of 5x plus 15 is less than negative 30. We're going to divide by negative 6 on both sides, reducing the negative 6. So we get the absolute value of 5x plus 15 is less than positive 5. And notice we have, oh, I made a mistake. I apologize. The inequality is supposed to flip. I divided by a negative. So this less than symbol flips to a greater than symbol. So now we have an or statement. It looked like an and statement at the beginning, but it's actually an or statement. So now we're going to make two inequalities. 5x plus 15 is greater than 5, or 5x plus 15 is less than negative 5. And now we're going to solve. So we're going to subtract 15 from both sides, eliminating the 15, and we get 5x is greater than negative 10. Dividing by 5, we get x is greater than negative 2. Over here we're going to subtract 15 as well, eliminating the 15. We get 5x is less than negative 20. Dividing by 5, we get x is less than negative 4, and this is an or statement. So my two critical values are negative 2 and negative 4. So I can draw these on the number line now. So here's my number line. I've got negative infinity on the left, positive infinity on the right, 0 is somewhere in the middle. Now negative 2 is to the left of 0, so we're going to mark negative 2 right here. Negative 4 is further left, so we're going to mark negative 4 to the left of negative 2. So now we need to determine, do I have open points or closed points? I do not have the or equal to part. I just have x is greater than negative 2. So this is an open point. On the other one, I have x is less than negative 4. I do not have the or equal to part. So negative 4 is also open. Now this is an or statement. Since I have an or statement, I'm going to shade outside my points. And now we write interval notation. Interval notation starts at negative infinity because we shaded all the way to negative infinity. Infinity always has parentheses, so we're going to use parentheses, negative infinity, comma. We shade until we get to negative 4, so we're going to write negative 4. Negative 4 is open. When a point is open, we use parentheses. Now we have a break in between the two numbers. When we have a break, we use a union. So we're going to put a U, which represents union. And now we're at negative 2. Negative 2 is open. Since it's open, we're going to use a parentheses. We're going to write negative 2, comma, and we shade until we get to infinity. And since it's infinity, we close with a parenthesis. And that's our solution to example 2. Well, I hope you enjoyed today's lesson where we continue talking about solving absolute value inequalities. If you have any questions about this topic, I know there's a lot of information. Go ahead and send me a message in Schoology, or you can send me a text and I'll try to help you out. Have a great day.